Good morning, everyone. Welcome to your lesson for this Thursday. We are now looking at dominance matrices. So this video is hopefully going to give you everything you need to know about dominance matrices so that you can do the questions that I put at the end. All right, so why do we need dominance matrices? Basically, we use them for ranking. So we rank, for example, you can see up here, we used for ranking round robin tournaments. So in sports such as tennis, golf, soccer, AFL is a round robin tournament. So it's a way to rank the order of how the teams or the individual players are. So we need to use edges. So remember, this is an arc because it has a direction on it. So we will be using directed networks. And what this means, so say this is node A or player A and player B, this means that A is dominant over B. So if, for example, it was a tennis game, A beat B. So I will show you what this will look like as a network. So we've got a bit of information here. A school table tennis tournament, person A beats person D, person B beats person A, D and C, person C beats person A and D, and person D doesn't beat anybody. So let's draw a network. The first thing I would do is I would draw my nodes or my players, and then I would start creating my network from the information. So A beats D, so I have drawn an arrow from A to D. Then person B beats A, D and C, so I have arrows going to all of them. And person C beats A and D, and person D doesn't beat anybody. So the next thing I can do is I can create a network from this. I can create a matrix from this network. So a 1 is a win and a 0 is a loss. So you should only have 0s and 1s in your dominance matrix. We can't differentiate for draws. So what this means is we call this a binary situation. So you either win or you lose. We're not including draws in this. And element, this is just an example, so this would be for all sort of pairs. So this means row 2 column 1. So if I'm looking at row 2 column 1, that is this one here, plus row 1 column 2, they should both equal 1. So 1 plus 0 adds up to 1, which makes sense because this would be when B was dominant over A, but A was not dominant over B. So then what we can do is we can create a dominance vector, and this is basically what it's doing is we are just adding up each row to see which player or team is ranked the highest. Now you can obviously, this matrix here is pretty straightforward. I could do this in my head. So this would be a 1, this would be a 3, this would be a 2, and this would be a 0. As your networks start to get more complex, it'll take more time to add up each row. So what you can do is you can multiply your dominance matrix by a column vector of 1s, and I'll show you what this looks like now on my calculator. So you can see I'm going to go into matrix. I put it in here down as mat E, so I've got a 4x4, and you can see that that is exactly the same as this matrix here. Then in mat F, I'm going to put a 4x1, and then I'm going to fill this with 1s. Yep. Then I exit that and go back to my main screen. And then I'm going to go mat E, and that helps because I actually did label it here, times by mat F, and I'm going to save it as mat G, and you can see that is exactly what we would have got by just adding it up. So that's how you do that one, and that is a dominance vector. So what this does is it ranks the players from highest to lowest. So if I was ranking, I have a 3 here, so B is the highest. You can't see under here. C is a 2, so that is the second. A is a 1, so it is a third, and underneath my head here is a D, is a 0. So then this would be how we'd rank the teams or the players. All right, now I just want to show you what happens when they get a little bit more complex. So you can see this is now a 5 by 5 matrix, and I have done my dominance vector here. Again, at the moment, the way it is right now, I could easily go 2, 1, 3, 2, and 2, and I could do that quite easily by hand. But I will just show you one more time how to do that on your graphics calculator. So I'm just going to delete the one that I had up before. And then into my matrix, I had already filled this matrix in, so I've called this one mat A, my 5 by 5. I'm going to make my column of 1s, so it's a 5 by 1. I'm just going 1, 1, 1, 1. And then back to my calculation page. So then same thing, shift mat alpha A times by mat B, and what you will see is we had the very same dominance vector that we just had before. So that's how you do that one. And don't forget, you can use the arrow to save it as whatever you want to save it as. So what we can see here though is that we have 3 players that are evenly ranked. So what do we do here? So when our networks get more complex or our teams get more complex, our first order dominance isn't always enough. So direct wins isn't always enough to differentiate who is going to be the overall winner. So from that example before, Team C was the clear winner, but then we had A, D, and E. They were equal second, and then Team B was the lowest ranking. So we need to be able to separate these 3 teams here. And the way we do that is we are going to calculate our D squared. So what this will look like is, all right, I'm not going to show you how to do this on your graphics calculator because I'm very confident that you guys already know how to do that. So this would be, I had my original dominance matrix saved as mat A, so I would just do mat A squared. And then I could times that by my column of 1s, so which was saved as mat B, and that would give me this one here. So, and let's interpret what your D squared, so your second order dominance matrix is. So what this means is E has 2 second order influences over A. So it means that even though we're not looking at if E directly beat A, but E beat B and player B beat A. So then through, I guess, second order dominance, we're saying that it's predicted that because E beat B, they would also beat A. And then the other one is this one here. So because E beat C and C beat A, so E is dominant, has a second order dominance over A. when we are looking at this though, we can't just do dominance plus d squared, because your direct wins are always going to be more important than your indirect wins, because an indirect win is still an assumption. So we're assuming that what was it? So E beat B, so we're assuming that E would be A, but you don't know that for a fact, whereas your dominance ones is from data that we have already collected, and we know for a fact that E did beat B. So what we do is we have this equation here, and we put a half for your second order. Now the half is an arbitrary value. It means it doesn't have to be a half. It could be a quarter, it could be a third. In the context of a specific question, they might give you the value that they want you to put in front of your d squared, but it's to reduce the impact of the d squared. So it just means that your dominance matrix is the most important one, and then we're going to use half of the d squared. So we're still going to use it to try and differentiate the players, but we're not putting as much value on d squared because d squared is an assumption. So yeah, it's to reduce the impact of d squared when ranking the players, because our first order ranking, so our initial dominance matrix, is always the most important because that is the one that has come from direct data. So if I did this matrix here, and I'm going to show you how I did this in my calculator. So I'm still looking at that initial matrix from before, so it's still mat A is still in there, and I'm going to go shift A plus half mat A to the power of 2, and what you can see, then I'm going to save this, and I think I save it as mat C. No, I saved it as mat D. And then I get this matrix here, which you can see matches with this matrix here. And you can see as you start to get like half values, that's going to make it harder to add up manually. So now I'm going to do mat D times by mat B. From my last question, I had mat B as my column of ones. And then I'm going to change it to decimals because I prefer decimals. And we can see now we have a dominance matrix. And it came out to be Team A was 4, Team B was 2, Team C was 5.5, Team D was 3.5, and Team E was 4. So what we can see is we have been able to, we still have equal second with A and E, but we were able to differentiate against D. So we could say for this one that Team C is ranked first, Team A and E are equal second, Team D is third, and Team B is last. So, one more little bit of information. If we do D plus half D squared, and that isn't enough to fully separate the rankings, we can then have a look at D to the power of 3 and D to the power of 4. So this is obviously indirect wins to your third order, and this is your indirect wins to your fourth order. So what our equation would look like if we were looking at a third order dominance, we could have D plus half D squared plus a third D to the power of 3. So every time you add a higher order dominance, you want to reduce the value that you are putting in your entire matrix. So we've just gone with a third. If I needed to go to D to the power of 4, I could do plus a quarter D to the power of 4. So what I would like you to do now, don't worry about this because you guys are all online, is exercise 9C, page 260, questions 1, 2, 3, 5 and 6. And you'll need all of them done before tomorrow when we move on to transition matrices. Good luck. Let me know if you have any questions. Bye.